For this video, we're going to look into taking the equation and writing it as a log form. We're also going to take log form equations and change them into exponential form. And we're going to evaluate a few logs without the need of a calculator. So let's start with this one over here. It says to write the equation in a log form. So on this one, you just have to remember how we talked about it, right? So when you talk about 25 here represents a base. A base is always raised to a power, and whatever's on the other side of the equal sign, it's your answer. So when you're changing from exponential to log form, you take the log of your base, in this case our base is 25, of your answer, our answer is L, and we set it equal to your exponent. We set it equal to your power. So for this one, it's just a little bit easier to remember the wordings and see how it changes. A base is raised to a power exponent, and this is equal an answer. So you take log of a base of the answer equals your exponent. So that's how you can change it. Same idea. When you're going from a log to exponential, we know the 7 right here represents your base. Whatever's on the other side, it represents your exponent. So whatever's in here, whatever we're taking the log of, it's our answer. So to change this from a log to exponential, we take a base. In this case, our base is 7. Your base always gets raised to an exponent. In this case, our exponent is r, and this is equal to your answer. Our answer is 2. So that's how we change log 7 of 2 equals r into 7 to the power of r equals 2. So now let's take a quick look at how to evaluate without using a calculator. So for this one, you have to go back and remember and practice the properties of logs. So we have a base 10 raised to a log of 4. If you don't see a base in the log, remember it refers to your common log. So it's understood to be a base of 10. When you have a base raised to a log of the same base, it's just going to equal whatever your answer here is. So 10 raised to the power of log base 10 of 4 is simply going to be 4. Same idea here. You have e to the power of ln of 6x to the 4, right? In this case, you're dealing with e raised to a natural log. Natural log is understood to be log of a base e. So you can think about they're kind of like opposites to each other, right? So if you have e to the power of ln to something, it's just going to equal whatever we have here. So our answer is going to be 6x to the power of 4. E to the natural log of something is just going to be whatever's in there. 10 to raised to the same base, raised to the log of the same base is just going to be whatever it is here. And now we're dealing with log base 2 of 1. So this one, you can think about what this is asking is 2 to what power, right? Because we're missing the exponent part of it. 2 to what power is going to equal 1. Anything to be equal to 1 when raised to a power, the power must be 0. So 2 to the power of 0 is equal to 1. That's why we said it doesn't matter what your base is. Anytime you see log of 1, it's always going to be 0.